Now, as we go on to section 2 of chapter 3, a couple of things in class I would have written on the board. We have some major equations here. AX plus BY equals C. We're saying that this is called the standard form of the linear equation in two variables. And I often say this is equation number 1. And equation number 2 is a modification of this. If you solve for the letter y, you'll end up with y equals mx plus b. And this has a special name. This is called the slope-intercept form of the linear equation, and we'll be getting into both of these in more detail in later sections. But these equations can all be represented by graphing them somehow on a rectangular coordinate plane. So one of the first things we're going to be doing, and eventually we'll be graphing these, is to identify whether something is a linear equation or not. And by the way, the word linear refers to a line. If your points of data, as we see illustrated here in a sense, and if I take a line, they fall into a straight line, then that equation that gave rise to that line, that's represented by that line, we say is linear. So we're asked then to graph an equation. And there is a protocol, there is a way to do it. And since this one hasn't started too much, I will actually show you using this one here. And you would start off by making a T-chart that we mentioned in the previous lesson. And you're going to put some points for the x value. And we said a good one would be a -1. Another good one would be 0. And we could also put a 0 in the y column. So let's solve then for the other points. Well, if x is a -1, this is a -1 here. In fact, I'm going to make that a -2. You'll see why here very shortly. All right, if this is a -2, I'm going to transpose that over. This then becomes a -2y equals a -2 on this side becomes a positive, so that becomes an 8. Now we divide both sides by a -2, and we get a -4. So when x is a -2, y is a -4. All right, now how about if x is 0? If this is a 0, then we're just going to divide -2 into 6 now, and that's going to be a -3. Now if y is a 0, here we just put that as a 0. 2 times y is 0, so we get x equals 6. Now I now have 3 sets of data that I can plot on this graph. So -2 negative 4. Negative 2, oh, they did that one too, so it's right there. Then 0, negative 3. There's 0, negative, oh, they did that one too. And then I have 6, 0. I have that one too. Okay, good. Now they also have this one. And you might say, are there other points? And the answer is yes, because these lines extend in this direction and in this direction to infinity, and out this way is negative infinity. There is an infinite number of points along this line. And what this line does is a graphical representation of this equation. This is this, graphically represented. Okay, so let's see where they go with the textbook, because I'm anticipating that's what they're going to be doing here. Okay, so there's that first equation we talked about. This is in standard form, and you'll need to memorize that, or again, try to commit it to memory as best you can. So let's see what they're asking us here. And by the way, all of these are linear equations. Even though this one only has one letter, the value of x there is 0. That's why they're not writing it. But these are all examples of linear equations in two variables. Again, the x is a 0. That's why we're not writing it. All right, determine whether each equation is a linear equation in two variables. Now, a key also is that your exponents on these variables are only a 1. And then that's a giveaway here. So this is linear, this is linear, this is not linear because of the exponent being higher than 1. And again, the y is 0 here, so this is linear also. That was easy. And we'll do this one too. Linear, because of the squared, not linear, linear, linear. Okay. Now here they want us to find 3 ordered paired solutions. And the strategy for it would be to make a T-chart. X, Y. Now we say in geometry you only need 2 points to make a straight line. We do a third point to give greater accuracy. Or as the Valley girls say, for sure, for sure. Anyway, a little joke. So which points do you choose? Well, again, you're allowed to choose any, and you try to stay away from fractions. But sometimes you just have to have them. So we will choose, again, a good choice would be a -1, a 0, and a 1. Now you can change these. They don't have to be these. But you want to stay toward the origin because you'll be plotting these probably shortly. Okay, so we have here if x is a -1. So if x is a -1, this becomes a negative 2 plus y equals 5. Transpose that, we get y equals 7. Oh, I think I messed up on that one. Come think of it. Let's try that one again. Am I doing this right? Yes, I was right because I was looking over here and they were using a positive 1. That comes up later. Okay, now if x is 0, y is going to be 5. Now, if x is a positive 1, this will be a 2 here. And now if we transpose the 2 to the other side, it becomes a negative 2. And that makes that 3. Okay, there we are. Now, one of the things we're going to be doing, and I might just as well show it to you right now, is we're going to plot these. So in your study homework log, I should say, you're going to be graphing these. So we put up some points here. A negative 1, 7. So there's a negative 1. And we go 1, 2, 3, 4, 5, 6, 7. This is just going to be a sketch. Now, if it's 0, then we have a 5. So we'll put a dot right there at 5. And if we have a 1, which is right there, we go up 3. And I don't know if you've noticed, but we now have a straight line. So this line now is the graphical representation of this equation. So graph the linear equation. So the first step would be to make a T-chart and get 3 points so that you can get greater accuracy. And then, by the way, if for some reason you had a point that was like out here, you had 3 and then 1 that was out here, this is probably an error because a linear graph will be a straight line. Okay? I could remember when students were just hand drawing these and not using their computer, they would have a line like that. Can't do that. Okay. Well, let's see what they're showing us. So they're saying get some points. And then once you make your little T-chart, and they're using 1, they're not using a negative 1 in this. Again, you can use any points. There is your particular graph. All 3 points should fall on the same straight line. If not, check your ordered pair solution for a mistake, the one that is not on the line. Chances are you might have messed up with a sign. I can do it still, even after all my practice, because I get, stressed out a little bit. I'm sure you do too. Okay, now, as we move on, by the way, there will be some easier ways, some shortcuts that we will follow. So let's just take a look at this one here. Again, I would strongly suggest that you use a T-chart as the method best served for this type of work. Now, here they're introducing something, and I like this because I want to do this too. And this is a special kind of T-chart. Now, in this T-chart, we have an X and a Y, but we only have 2 points. We put a 0 there and a 0 there. And this type of T-chart is particularly useful when your equation is in standard form. So watch what happens now. If x here is a 0, x here is a 0. Negative 5 times 0 is 0. So we then just have 3y equals 15. Well, what will y be? Y is going to be a 5. Now here, if y is 0, and we're going to say negative 5x equals 15, our x here is going to be a negative 3. Notice when you plot just these 2 points, you have a value in which you have a 0 here and a 5 here. Remember, we said whenever you have that, your first item is a 0. This is going to be on the y-axis. So 0, 5, right there. And now, if your first term's a number and the second number is a 0, this is going to be on the x-axis, right there. And you have done what we call a special situation where you have plotted, in this case, the y-intercept and here the x-intercept. We'll be doing this soon here. And just with these 2 points, by plotting the intercepts, and what are we referring to? Where the graph will cross the y-axis, that's the y-intercept. Where it crosses the x-axis, that's the x-intercept. And we use this special T-chart that I'm calling the X and Y Intercept T-chart. Now a little more information that we'll be getting to shortly, or in later lessons, is that another way of looking at this is the ordered pair 0, B, and this is the ordered pair A, 0. We would also, I saw this earlier and I just didn't introduce it, that sometimes the ordered pair, instead of being written XY, is written A, B. Again, still alphabetically, still an ordered pair. And when this is a 0, this is the y-intercept. And when this is a 0, that is the x-intercept. Okay, lots of stuff going on here, and you could put a third point in there to get another value, make it accurate. Let's do example practice 3 here, using our x and y intercept T-chart. X, y, 0, 0. So here, if x is 0, y is going to be a negative 3. Here, if y is 0, x is going to be a 4. So to graph that then, negative 3, 0, 1, 2, 3, dot there, and then 4, 0, 1, 2, 3, 4, and then there's your line. Ta-da! Okay. It's in standard form. A good technique is to use that special T-chart. And what we've done is we've plotted the intercepts, the y-intercept, the x-intercept. the y-intercept, the x-intercept. And you'll be asked to do this later. We're just sort of giving you a thumbs up at this stage. Now, this is sort of a special case here, where we have the equation y equals 3x. Now, if you use the x and y intercept T-chart, you'd find that all of these are 0. So when there is no other term out here, and there's only the y equals something x, you can't use that because we know that this type of equation is going to go through the origin. So we need at least one other point. So let's say 3 is 1. So, I'm sorry, x is 1. 3 times 1 makes this a 3. So now we can go over 3, I'm sorry, over 1 up 3, which is right there. Now if we made that a 2, we would have this as a 6. So we'd go over 2 up 6. And there's our straight line. And there's our T-chart with some background. It's a special case where there is no other value out here. And again, there's lots of stuff going on here, and I may be confusing, so I want to be sure I don't do that too much. All right, so for this one, let's plot this one too. So make a little T-chart, x, y, and again, we'll just use a -1, a 0, and a +1. So if x is a -1, -2 times -1 makes this a 2. And if x is 0, y is 0. It's going to go through the origin. And if it's a +1, this becomes a -2. So when we graph that, it'll be -1, 2, 0, and then 1, a -2. And there's our line. Okay? All right. This is one of my favorite chapters, by the way. I don't know if you realize it here. Okay, now as we make a T-chart for this one, I did mention this before a little bit. Would you use a -1 here? And the answer would be no. Why not? Because you'd get a fraction. So this, we're going to use a -3. And this one, we're going to use a +3. And this is going to be a 0. Now, why did I choose those? Because by using multiples of 3, my 3's are going to cancel out here. All right, let's see what we get. So -3, and -3, this becomes a +1, plus 2 is 3. All right, if this is a 0, this is a 2. Now, if this is a +3, this now becomes a -1. -1 and a 2 is a 1. So there are my 3 points. -3, 3. -3, 3. They're using that one. 0, 2. they're using that one. And then 3, 1. So 1, 2, 3, 1. They're using that one. Now they used another one too. That would have been the x-intercept here, which is another good one to use as well. Remember, there's an infinite number of points, and you want a strategy for doing it, and you have to be careful with the signs. I can make a mistake, but again, check your work. All right, let's do 5 while we're here. Now there's a 2 there, so I'm going to use -2, 0, 2. So this is -2, so this is a -1, so this becomes a 2. This is 0, so that becomes a 3. This is a +2, so this becomes a 4. So -2, 2, -2. Oh, it's not that graph. We're going to make our own graph. I'm saying, boy, that's off. -2, 2, right there. 0, 3, right there. 2, 4, right there. And there's your graph. All right. The nice thing about MATLAB is the tools that they have. You can make very, very accurate graphs. When you're sketching them in your homework log, that's just to emphasize and give you practice on your skill. Okay, now example 6 is a special case. And maybe in class on the board I had equation 5, which we said y equals b. And later we're going to have equation 6, which is x equals a. Well, you may or may not have recalled from an earlier part of this lesson, a comma 0, that is your x-intercept, and 0 comma b is your y-intercept. Well, this ties into these equations. When you see the special form of this equation right here, y equals b, it's telling you it's going to be a horizontal line going through your y-intercept right there. And for this one, x equals a is a vertical line going through your x-intercept at -2. Now, you might say, how am I expected to remember all of this? And I know that's a challenge, but again, practice and study. It's not a casual thing. I know I can't look at something once and remember it, but I try to look at different little techniques and things. Again, if you can memorize these things, put them on an index card, all these formulas that we have, and then just review them from time to time. Very, very useful for Chapter 3. Okay. Now, here they're giving us 2 graphs. this one and this one, or two equations that we are going to graph, on the same axes. And what do you note about these? Well, notice they are parallel lines. And if you went from this point to this point, how many units away are they? Well, they're 6 units away. So this is leading us into something here that we're going to take a close look at. And that is, in a sense, this graph has been shifted up, like from here to there, 6 units. And that 6 is sort of an interesting thing when we look at this graph. It's been shifted up 6 units. You're going to be using this in other courses too. So as we compare these two graphs, or equation, so we're going to take a look at the practice, example 7. And what I'm going to do is set up these two equations for you. And we'll just look at them for a moment here. Now, keep in mind this is in slope-intercept, y equals mx plus b. And as we mentioned before, b happens to be the y-intercept. So this 3, I put a dot on my equation, 1, 2, 3, or the graph of the equation. And this one is y equals mx, where there is no b. When we said there is no b, this is a 0. That is, it indicates it's going to go through the origin. So right there. Now later we're going to look at the slope, which is what m is. That comes up in a later section. But -2 slope looks like this. It's in a sense over 1 up 2 over 1 up 2. And notice that now comparing these two equations with 0 intercept here and a 3 intercept there, this graph has the same slope but has been shifted up 1, 2, 3 units. And this is what they're having you to look at in this particular example. Okay, we're going to go on now to the last example of section 2, and it has to do with estimating the number of registered nurses. Well, after lots of study, they have come up with the equation to represent this as this equation right here. Now below there is a graph of this equation. And what can we pick out about it? Well, this is your y-intercept, where it would start on your graph. Let's just make a little graph over here fast. Let's say this point is 2619. And it's going to go up like so. And this will be time. X is usually time in years. So there's some data they're giving you. They're going to put it in this particular equation, and they're in a sense solving for y. And they get this particular graph. Now, as we mentioned earlier, notice that this little part right here indicates a lot of the graph has been left out, because we're only interested in this area up here where the graph actually applies data. So if this is 2008 right here, this is years after 2008, this would be 2018. And we had our data and it went up like this. It looks linear, it's a straight line. So we would go up there and then go over here and we could predict. That's what they're suggesting here. We're going to predict the number of nurses in 2018. Now, there are some words associated with this type of predicting that they're not introducing here, so I'm not going to do it either to confuse the issue. Okay, well, let's go on. Now, for those of you who have graphing calculators, there is some information here that you can read over, but we're not going to make this a regular part of our course because not everyone has a graphing calculator. And that will wrap it up.